Hello, eighth graders. I hope that you are having a good day, that you are doing well while I am away. We're having a great time here. God is speaking through His Word, and we are doing well, having fun. Anyway, I'm not with you. Well, I don't know if I wish I was with you. I'm pretty happy to be here on the trip, but I do miss you guys, and I hope that you are doing well. So you had your quiz on stars and the moon. I hope that went well for you. I hope everything was pretty self-explanatory, and you can, amaze your friends and family by looking up at the sky and seeing, hey, that's a waxing gibbous moon. People be impressed, let me tell you. Anyway, while I'm recording this, I do hope there's not too noticeable noise in the background. I'm alone in a big room, but there are other places with people in it, and it's a game room, and so I hope it's not coming through. But if it is, I apologize and just try to do the best we can. So today, as we start our second half of the outer space crash course, we are going to talk about planets. Perhaps you have received some instruction about planets before. I know that several elementary classes do regularly talk about the planets, so you may already know some of this stuff. Obviously, this is a crash course. We're not going to get into a whole lot of detail. Just hit the highlights and call it good. But before we talk about the individual planets, we need to talk about what exactly a planet is. Because within your lifetime, I think, more or less, um, we used to have another planet that no longer is considered one, which raises the question, what exactly do you have to do or be or not do or be in order to be considered a planet, right? Poor Pluto got demoted. Why? Well, let's talk about what criteria, what qualifications scientists use to decide if something deserves the classification of planet. First one, pretty easy. You have to orbit a star, right? If you don't orbit a star, you're not a planet. A human being is not a star. Excuse me. A human being cannot be a planet. We don't, number one, right? We personally don't orbit a star. We're on something that orbits a star, but we personally don't orbit a star. The moon can never be a planet because it doesn't orbit a star. It orbits the planet Earth, right? So you have to orbit a star. Our star, of course, we call the sun. So does Pluto do that? Yes, it does. Pluto does, in fact, orbit the sun, which is a star. And so it did meet criteria number one. Number two, they have to have enough gravity to squish themselves into a more or less spherical shape. It doesn't have to be a perfect sphere. The Earth's not a perfect sphere. The Earth is sort of squashed. It's wider at the equator than it is at the poles if you flipped it upside down. Like if you took a bouncy ball and you kind of squished it between your hands a little bit. So it doesn't have to be perfect, but you do have to have enough gravity to create, or really, I should say, maintain a round shape because God gave them their shapes. Sorry about that. I don't know if you heard my radio go off or not, but anyway. So does Pluto meet that qualification? Well, unfortunately, it does not. Pluto is distinctly potato shaped. Um, a round potato, I'll give you, but still, it is too far from perfectly spherical to really truly meet that qualification. It's close, and if that was the only thing keeping it from being a planet, well, they might have been able to let that go. But we have a third criteria, and that is you have to have enough gravity to capture anything in your orbit and turn it either bring it down to your surface or turn it into a moon. Right? So basically what that means is there's lots of stuff floating around up in space. We think of it as a big open empty space, and it is just because of the immense distances involved, but there's tons of stuff up there. And anything that passes through your orbit as a planet candidate, you have to be able to pick that up with your gravity and either drag it down to your surface so it becomes part of you, or capture it and make it revolve around you, rotate around you, orbit around you, and basically turn it into a moon or a satellite, I guess is really a better term. right? Um, so again, here Pluto fails to do that. Pluto has a bunch of stuff in its orbit, a bunch of garbage in its orbit, comets, asteroids, just chunks of rock floating around up there that it has not managed to do either of those things with. It does not have enough gravity to affect those objects enough to turn it into a moon or bring it down. And it does have a moon. Pluto does have a moon, although I guess it might not really actually be a moon if Pluto's not a planet. But anyway, Pluto has something that could count as a moon if it was a planet. But unfortunately, it doesn't really orbit Pluto. They kind of orbit each other. They kind of twirl around each other. Neither one dominantly holding the other in orbit. And so, because it is just not quite round enough, and because it definitely has not cleared its orbit, has not captured anything with its gravity, it just doesn't meet those two criteria, and so it got demoted. There's two. I've heard two terms applied to Pluto. I think the one that's currently in fashion now, the one that's currently more accepted now is a dwarf planet. I like Planetoid. Planetoid was pretty popular when it first got demoted. I still like it better because Dwarf Planet makes it sound like it is still a planet, just a small one. Remember, like we talked about dwarf stars, right? Dwarf stars are still stars. So I like the slightly different name Planetoid. But that's just me. I'm not an astronomer. I have no say. Either of those terms, in my opinion, is acceptable, Planetoid or dwarf planet. And that's why Pluto does not get to be a planet anymore. Speaking of orbiting things, um, planets don't orbit in circles, right? We have this idea sometimes, especially if you've made a model of the solar system, that the sun is at the center of the solar system, and then all the planets orbit in a circle around the sun. Well, there is some truth to that, but it's not a circle. It's what we call an ellipse. You would call it an oval. It's not an oval, mathematically speaking, it's an ellipse, but you would call it an oval shape. And the sun isn't at the center of that oval. It's actually slightly off center at a point called a focus. Again, this is the crash course. We're not going to get deep into that, but just understand that when a planet orbits the sun, it's not doing so in a circle, it's in an ellipse, which means there are points in a planet's orbit where it is significantly closer to the sun than others. And we talked about that, I believe, a little bit earlier in the year, how right? Sometimes well-meaning people trying to talk about how perfectly created how perfectly God created and designed our planet for life. To talk about we're in the exact right spot for, just warm enough, but not too cold. And we are. I don't dispute any of those ideas. I do dispute the um, margin of error, right? Because I've heard people say, if we were 10 miles closer, we would burn up. No, no, we are hundreds, maybe thousands of miles closer to the sun or farther from the sun at any given point in a year. Um, so yes, there is a place where it's too far away, and there is a place where it's too close, but it's a range of thousands of miles when it comes to that measurement. Because again, we don't orbit in a circle, we orbit in an ellipse. We talked about how the sun is not directly at the center of that ellipse. We measure distances in space a couple of different ways. For things really far away, like stars, I think we mentioned already light years, right? The distance that light will travel in a year. For measuring something far away like a star, that's a great measurement, a great unit. For measuring things that are a bit closer, like our sun or other planets, we needed a slightly smaller thing because I believe if I remember right, the light gets from the sun to planet Earth in like 7 minutes or something like that, right? So when you're talking about the distance it travels in a year, 7 minutes is a pretty small chunk of time, and so we needed a little more workable unit. So what we came up with, scientists came up with, astronomers came up with, was this thing called an astronomical unit, or often abbreviated to AU. An astronomical unit is basically just an average of the distance between our planet and the sun, right? And I have to emphasize this thing. It's an average because, as I just mentioned a few minutes ago, we're not always the same distance from the sun. We don't orbit in a circle, right? But if you take all the different measurements throughout the course of a year, average them together. The distance between our sun and us is an astronomical unit. In number terms, that is 93 million miles. Okay, that's our nice round average number. The distance between the Earth and the sun, one astronomical unit, which means that any planet that is closer to the sun than us is less than one astronomical unit away. And any planet that is farther from the sun than us is more than one astronomical unit away. Of course, there are actual numbers attached to those, but just as a generality, we're right at one astronomical unit, and other planets are either closer than us with less than one or farther than us with more than one. I hope that makes sense. Okay. When we talk about planets, especially the planets that we can see, not our own planet, we look up at the sky at them and we see them because of the light that hits them reflecting off of their surfaces, whatever that surface is, from the sun. Right? So the light from the sun shines off the planet. Not all planets reflect sun equally well. Some planets reflect the sun very well. Some planets less so. Of course, there's also differences in distance as well, but albedo is our measurement of how reflective the surface of a planet is. Venus has the greatest albedo. We can see Venus very well. It reflects light very well. And so even when the sun is still out a little bit, we can sometimes see Venus just because it is so shiny up in the sky. We've mentioned gravity a couple times. I just want to remind you, I think we've talked about this before, but gravity is an attractive force created by mass. Okay? Just having a bunch of atoms, the more atoms you have, the more mass you have. The more mass you have, the more gravity you have. So I, being larger than you, have more mass. Therefore, I create more gravity. Now, the amount of gravity that I create is pretty insignificant because I'm not that big. But when you're talking about something like a mountain that would produce gravity in connection with being part of the Earth, of course. But the larger you are, the more gravity you create. And that's a little bit of a simplification. Gravity is actually quite a complicated phenomenon, but for eighth grade, especially an eighth grade crash course, let's just keep that equality there. More mass equals more gravity. Less mass equals less gravity. Okay, so smaller planets have less gravity. Larger planets have more gravity, except just because you're big doesn't necessarily mean you have a lot of mass. We'll talk more about that later. All right. So let's talk about the 8 planets, and we will start with the inferior planets. Not inferior in that they are not as nice or not as good. Inferior only in that they are closer to the sun and therefore less than one astronomical unit, AU. You'll see it on the screen there, right? The abbreviation. They are closer than one astronomical unit to the sun. The closest of the inferior planets is, of course, Mercury. All of these planets are what we call terrestrial, meaning that they have a solid surface that's made of rock and metal primarily. And that's what it means to be a terrestrial planet. And all of the terrestrial planets are, all of the inferior planets are terrestrial. There is one terrestrial planet that is not inferior. We'll talk about it in a little bit. Mercury is the closest planet to the sun. It gets pretty hot in the daytime, almost 800 degrees, and it gets very cold at night, almost negative 300 degrees. But here's the deal. 1 year on Mercury only takes 88 Earth days. All right, so our year, and remember, a year is just the time that it takes to travel around the sun one time, right? A year is how long it takes to travel around the sun one time. Because Mercury's closer, it only takes Mercury 88 days to get around the sun. So like a quarter of our year. In one Earth year, Mercury can have 4 years, give or take. Right? Just because it's closer. Right? It has a shorter year. So that's kind of obvious. It's closer. It would have a shorter year. But also it's influenced by the sun's gravity in terms of its rotation. Remember, a day, if a year is the amount of time it takes for a planet to get all the way around the sun, a day is how long it takes a planet to turn around once, to completely rotate. On Earth, we rotate every 24 hours. It takes Mercury 59 Earth days to rotate one single time, right? So if day and night are roughly equal, that means on one side of the planet, it's 797 degrees for like 25 days, right? And it's just there's an evening, quote unquote, and a morning, quote unquote. But full sun temperature wise, you're gonna bake for 20 some days while you're in the day side. And then you're gonna freeze for 20 some days on the night side and then be, baked and frozen halfway in between, right? Mercury is just not a nice place to live. It's in fact it's hot enough that some metals like sodium that are found on the surface, they actually start to burn, and which is really cool looking. It would look really cool, I bet, but probably also be very toxic. So not a nice place to live. Then of course we have Venus, right? The next planet, the next inferior planet. So between us and Mercury, it's often called Earth's twin because it is very, very close in terms of size, shape, and density to planet Earth. In fact, it even has clouds like Earth has over a solid surface. There's several planets that have lots of clouds, but they don't have a solid surface. So in this way, Venus is like Earth. It has a solid surface, but it also has a very thick covering of clouds, much thicker than ours is. Uh, Venus gets even hotter than Mercury. It's farther away, but it gets hotter because that heat gets trapped, right? If it's 100 degrees outside, you're hot. But if you put a blanket over yourself and trap that 100 degrees and your body heat together, it gets even hotter, right? And that's what happens with Venus. They have an atmosphere made out of CO2, which is a natural reflector of heat, and then there's clouds which reflect the heat in. It just gets super hot. And not only that, but these clouds that I'm talking about, they're not nice, white, fluffy clouds made of water. Well, there's water in them, but the water is mixed with acid, right? Literal acid. It dissolves things. If you went to Venus, your spacesuit would start to dissolve unless you took special precautions to make it acid proof. So the temperature will kill you, and the sulfuric acid will kill you. But not only that, but there's such a dense atmosphere that it creates far more air pressure than we have here on Earth, right? You've experienced pressure before, right? You've gone maybe you've dived under the water in a swimming pool or something. You felt that pressure on you at the bottom of the pool. That's water. It builds up pressure very quickly, but the pressure of Venus, it's not water. It's just the air itself. The gas itself is so heavy that it creates literal tons of pressure on you, trying to squeeze you every minute of every day that you are on there. So there's three different things on Venus, environmental conditions on Venus that are trying to make life impossible there. Another cool thing about Venus is that it's backwards. All the planets travel the same direction around the sun, except for Venus. It goes backwards. It's like going to the roller skating rink, right? Everybody's going the same way around the roller skating rink. I think it's usually counterclockwise. But every once in a while, you get this one 5-year-old or whatever who gets turned around. He starts skating the opposite direction, knocking everybody over. Well, the Venus is the 5-year-old, right? It's going around the sun in completely the opposite direction, and it drives secular astronomers nuts. According to all their models for how our solar system could naturally come into being, only, ruling God out of it, like only natural forces, every planet should be going the same direction. And this one's not. It's going the wrong direction. And I know it doesn't sound like it, but that's a huge deal when it comes to physics. It shouldn't be doing that. And so they have to come up with all these possibilities of what could have happened to Venus to make it go the wrong direction. And usually they talk about something like, well, a comet or something hit it, or another planet hit it, and then like that's there wouldn't be a planet left. When one planet hits another, it makes an asteroid belt or something like that, not another planet, right? It's not. It's just that's not. but it's the best they got because I firmly believe that God put Venus in the way it rotates just to confound the people who think that they are so wise in trying to explain God away from creation. We're going to skip Earth because we've been talking about it all year long. Um, it's the planet you live on, so hopefully you know plenty about it now after most of Earth science. So now we're moving to the superior planets. Again, not superior because they're just so great, just superior because they are farther from the sun than we are. They have more than one AU in terms of distance. Mars, the only terrestrial superior planet, is one that gets talked about a lot, especially here in America. We're very interested in Mars. There's a couple of reasons for that. One of them is that it is the only planet that has semi-normal temperatures, right? During daytime temperatures, especially on their summer, if you will, the temperature is 32 to 77. Right? That's perfectly livable temperatures. I mean, 32 is a little chilly. You want to wear a coat, but you can wear a coat, right? You don't, as terms of temperature, you don't need this super insulated spacesuit to live on Mars. Now, you definitely want to be inside at night. It gets pretty cold, but even that temperature isn't very far off from temperatures that we have learned to cope with in Antarctica. We haven't gotten quite that cold, but we've gotten pretty close. And so we have the technologies available to us now, temperature wise, to survive Mars. There are some other problems, but temperature isn't really one of them. Gravity is a lot less on Mars. Our Mars is smaller than us, but it's not a third smaller. The problem is Mars, whatever Mars is made out of, it is a lot less heavy than what Earth is made out of. And we talked a little bit about this too, right? We said that Earth has a core of metal, at least that's what we assume, because our planet's heavier than it should be if it was just rock. Well, Mars appears to be just rock and is about the weight we would expect from a planet made mostly just of rock. So if you went to Mars, you would weigh a third of what you do now. So let me just throwing out a number. If you weigh 100 pounds here on Earth, which most of you would probably weigh a little less than that, but if you weighed 100 pounds here on Earth, that means on Mars you would only weigh 33 pounds, right? So, assuming you could get to Mars with the same amount of muscle power as you have here on Earth, and it didn't just waste away, you could jump 3 times as high, right? Because you have a third of the gravity holding you down. It's not like you can launch yourself off the planet, but you can perform uh, bigger jumps and leaps and that kind of thing than you would expect to be able to. Jupiter, but because of this gravity, by the way, also it has the largest mountain on Earth. On Earth, oh my goodness, has the largest mountain in the solar system because there's less gravity pulling the rocks down. Right, that actually has an effect on how tall mountains can be. Jupiter's the biggest planet. You could literally take all the other planets, double them, and they would still not quite equal the size of Jupiter. When you look at Saturn, you're like, well, Saturn's awfully big. Yeah, Saturn is pretty big, but because these are spheres and volume increases, it basically more than doubles. What's the word I want? It squares with every increase in diameter. It's significantly larger, even though it doesn't look it. I understand, but I promise you it is. All right, it is a Jovian planet, which means that it is entirely made out of gases. Now, there are some scientists who speculate that the pressure of all these gases not solidified, has turned some of these gases into liquid very close to the center. And that may be, but it's still not a normal rocky planet, right? Like all the others we've talked about. So whether it's completely gas or whether the pressure squeezes that gas into a liquid at some point, it doesn't really matter. It's very different in composition than any other planet that we've talked about. It's got a permanent hurricane on it. It's called the Great Red Spot. You can see it there in that picture in the bottom left-hand side of Jupiter. We assume it's permanent. It's been there as long as we've been looking at it. It's in terms of scale, just to show you how big Jupiter is. I think you can fit 2.5 Earths inside that storm, right? So it's a hurricane, 2.5 times the size of Earth. Saturn is the one with the rings. It's pretty famous. We're not going to spend a lot of time there. Those rings are made out of just chunks of rock and dust and ice. So they're not very substantial. There's lots of space between the chunks, but from a distance, they all kind of shine and create the illusion of a solid band. Okay. Hence, Saturn has a ton of moons, 31. Actually, Jupiter has more. I didn't really mention Jupiter's moons. Jupiter has like 67 or something like that. Saturn's got a lot of moons, though, too, including one very interesting one, Titan. It's about the same size as Earth. It has an atmosphere. It's not terribly bad temperature-wise. It's actually a lot of scientists think that it's actually our best bet for creating a colony, even better than Mars. It's farther, but it's got a lot going for it in terms of being a place that people might live someday. Saturn. Uranus or Uranus, I've heard it's pronounced both ways. It's mostly made out of methane crystals. It rotates on its side. This picture has it rotating more or less the normal planetary way, but actually it is actually kind of tilted so that it rotates more or less on its side. I just didn't want to tilt the picture because it would take up more space. But yeah, it rotates on its side, which again is another thing that evolutionists, well, I shouldn't say evolutionists because it's not biology, but that secular scientists just hate because there's no reason it should be spinning on its side. Everything should be spinning in the same direction, spinning and orbiting in the same direction. So anytime there's not, it's an anomaly that they have so much difficulty explaining. Neptune, I'm sorry, I cut off that. It's the furthest true planet. I mentioned Pluto. It's not a true planet. It's technically further out, but Neptune is the furthest thing that still qualifies as a planet. We found out about it mathematically first. We calculated things and we're like, there should be something there. We could calculate the effect of gravity on things that we were seeing in the telescope. And we're like, there is something mathematically there. We just can't find it. And then eventually someone did found it through a telescope. And so we discovered it mathematically before we visually discovered it. It's got a hurricane too, very much like Jupiter's, smaller, but much like Jupiter's. But because of the different color of the gases in the atmosphere, rather than being red, it is more of a dark blue. Poor little Pluto, the demoted dwarf planet, or planetoid as I prefer. Doesn't have enough gravity to make itself round. Didn't capture its moon, Charon. And that is the end. I do have two videos. One's kind of just a summary video. And then I know how much you guys love songs. So I found you a planet song that I hope you enjoy. Give me just a moment to cue that up and I will play them for you. All right, here's the serious video first, and then we'll do the song.
Our solar system is one of over 500 known solar systems in the entire Milky Way galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar...
Obviously incorrect, but this is a secular video, so that's the perspective that they're going to come at it from.
Gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster.
I don't think this
Only
is the video
15% of stars in the galaxy host planetary systems, and one of those stars is our own sun.
Yes,
Revolving around the sun are 8 planets. The planets are divided into 2 categories based on their composition, terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago, when the planet had a watery surface and moist atmosphere.
Yeah, so is it possible that God originally created Mars with water on it and it has since dried up? It's possible. There's no way of knowing. But they think that it had water on it largely because of some geological formations that, as far as they know, mostly occur when there's water around. This is another planet. Earth rules do not necessarily apply, and so them making these assumptions is problematic at best. Could it have had water? Sure. I have no problem. There's no reason that having water on Mars makes God's word untrue in any way, shape, or form. But them assuming there had to be water because they've observed some particular rock formations is a little bit of a stretch.
Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense. The largest Jovian is also the largest planet in the solar system, Jupiter. Nearby is Saturn, the solar system's second largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects.
All right. That's we're going to learn about that next, but we don't need to start that. All right, so here you go. For better or worse, here is your planet song.
There are 8 planets in the solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name is Mercury. I'm the second hottest planet, the closest one to the sun. A year on my surface is 88 days. I'm the smallest, but I'm lots of fun. My name is Venus. I'm the hottest planet, but the second planet from the sun. I'm the brightest planet in our solar system, and I'm too hot for anyone. My name is Earth. I'm the planet you live on, the third planet from the sun. I'm the only planet with organic life, so take care of me, 'cause we're all one. My name is Mars. I am red in color. I'm the 4th planet from the sun. I have the highest mountain in our solar system, a volcano named Olympus Mons. There are 8 planets in the solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name is Jupiter. I am covered in clouds. I'm the 5th planet from the sun. My giant red spot is a raging storm. As for size, I'm the biggest one. My name is Saturn. I am brown in color. I'm the 6th planet from the sun. My outer rings are extremely thin. They're made of dust and icy chunks. My name's Uranus. I am blue in color. I'm the 7th planet from the sun. Humans have named me the icy planet because I am the coldest one. My name is Neptune. I am blue in color. I'm the 8th planet from the sun. I have too many storms in my atmosphere, and I'm the furthest planet from the sun. There are 8 planets in our solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun.
There we go. All right, I hope you enjoyed that, and hope you learned lots. Do well, be good for your substitute, and I will see y'all soon. Love y'all.